Hello there. This is the first in a series of videos designed to introduce the essence of computer programming. Computer programming can be a lot of fun. As a creative activity, it lets you turn your ideas into real things. It's kind of like modern-day magic. Unfortunately, many beginners to programming struggle due to the fact that they actually have to learn three different things at the same time. First is the problem-solving techniques or algorithms. Second is the actual programming language that you use to express your solutions to the computer. And third is whatever tool you are actually using to build up your program, be it an IDE or text editor of some form. Rather than attempt to approach all three at the same time, these videos instead focus on the problem solving that is really the core essence of computer programming. If you are already learning a specific language, most of these concepts should transfer over pretty cleanly. In these videos, I'm using a visual programming tool I'm actually developing as part of an upcoming puzzle game, and I'll throw the link in the description. The nice thing about this tool compared to traditional tools used in programming is that the structure of your program is very visual compared to pure text that traditional programming tools rely on. You get to build up your program using blocks that you basically just put together visually, which makes it easier to build your program and also understand what it's actually doing when you have a program complete. At the time of recording, there is an early prototype of my game available on Steam that you can grab if you want to try to follow along. However, the sandbox mode that I'm using for these videos is going to be available in an upcoming playtest, as well as the final version of the game. It isn't yet available. If you wishlist the game, you will be notified as soon as I start the playtest, and then you can use that to follow along. With that little intro out of the way, let's build up some little programs and show you how this works. So at the bottom here we have what kind of looks like a hand of cards. Each of these are going to be words that we end up putting together to build up a little program. Here in the middle we have kind of a representation of what our program is. Right now it's completely empty. And on the left we have kind of a little preview of what the program gives us currently. And we'll see this evolve as we put some things together. So let's do some very basic sort of program. Typically when you build a program, you're interested in kind of one of two types of outcome. You're either interested in computing or calculating some value, or you're interested in having some side effect, some impact from running your program. And in practice, programs do some of both. But you can think of pieces of programs as doing primarily one of the two things. It's a little easier to think about the calculating side because most people are familiar with calculators, so we'll do something like that first. So let's do some basic arithmetic. So I just dragged the plus over to the program. These dotted lines represent basically inputs that need to be filled. Initially we saw one labeled root, which is kind of the starting point from our program, which is where I dropped the plus. Now we see that plus needs two inputs in order to do some work. So let's just throw some things in there, and this shouldn't surprise anyone, but we see that the result of adding 1 and 1 is 2 over here. And we can actually go ahead and click this run spell button and we'll see how that unfolds. Yep, so plus basically consumes the two inputs, takes in the two ones, and gives us a 2 as the result. Let's go ahead and try to build up this program a little more. In this case we added two numbers, and that's kind of a bare minimum. Plus requires two inputs. But what if we actually wanted to add up all of these numbers? Well, we can actually give plus as an input to this plus in a way. And right now we see it's unknown. We can't actually run the program until all the holes are kind of filled in. So just to help us visualize this, I'll fill them in with ones again. And now we see the result is 3. And kind of intuitively, we would expect that adding up 3 ones gives us 3, but how does that work? Well, let's take a look and see. Right, so just as we saw in the very first program, plus basically consumes its inputs and turns into the result. That's exactly what we see in this smaller chunk over here on the right. This plus sort of represents the sum of its inputs. So as we run the program, it's in some sense replaces itself with its sum, so that when we try to run the plus on the very top, we're actually doing 1 plus this sum, which was 2, to give us 3. We can go ahead and try some operations besides addition. Here we've got division doing just as we'd expect. Just as we expect, this 10 divided by 5 is going to give us 2, plus the 2 over here is going to give us the 4. We can run it and take a look. I'll talk a little more about precisely how this works in a future video, but for now it's okay to have kind of an intuitive approximation for what you think is going to happen, and going ahead and clicking on the run over here to test your expectations against reality. Alright, now that we have kind of a rough understanding here, I have 2 little puzzles. First, we're going to try to add up all the numbers here. Now, there are a lot of ways you could do this, but I'll just show 2 examples. So if you want to, kind of on paper, you could draw this out, or if you actually have access to the sandbox, you can go ahead and actually build the program. So yeah, go ahead and pause the video now, and in a moment I'll show you 2 possible examples. Alright, so lots of ways we could add up all the numbers. We could have ourselves a kind of chain like we did initially for adding up the numbers. Alright. And we could also imagine doing something a little more, we could say perhaps balanced, where rather than having all our blocks kind of in a long line, this one is a little more filled out. For the purpose of this exercise, it doesn't make a difference. I'll talk a little more in the future why some different kind of shapes for programs are actually kind of important. Alright, so we've added up all the numbers. How about a little puzzle, as I've kind of suggested in the corner here? Let's try to build up a little program that results in the number 108. And just like before, go ahead and pause the video if you want to work along on paper or with the program. And in a moment, I will show you 2 possible ways of doing this, as well as my thought process behind it. So go ahead and pause the video and see you in a bit. Alright, so let's make 108. So, kind of looking at the pieces that we have available to us, I'm thinking it might be kind of natural to try to build this as the sum of 100 and the sum of 8. So that would suggest that the very root of our program, the first thing we're doing, is adding up 108. And we'll just go ahead and throw in placeholders for now. We can flesh them out. So we're at 15. We can go ahead and work on the 100 side, which we can do is the product of 10 and 10. Nice. We are pretty close. So now I just need to fix up this right hand side. And yeah, we can do that as well as the sum of 5 and 3. Haha. So there is our 108. You can run it, see it. Just as expected. So that is one possible way. There are, of course, many ways that we could do this. We could also have attempted to essentially do 2 cubed over here. if you really wanted to, you could imagine doing a long sum of tens to get to 100. I'm not going to do that now. But you could. Because in computer programming, there are usually many ways to accomplish your goal. And in the beginning, I'm just going to be showing you how to put things together. So that about wraps it up for this first video. We've talked about why it might be nice to focus on problem solving rather than jumping in and attempting to learn a language, a tool, and problem solving all at the same time. Showing you how this little tool works and showed you some basic thought process behind building up programs to do some fairly basic things at this point. So I hope you enjoyed the video. If you want to leave in the comments, let me know what you thought, as well as letting me know kind of your previous experience with learning to know programming, which will help me cater future videos to people like you. So thanks, and see you in the next one.